Hello, everyone. Welcome to Dementia Basics. This is our fall rendition 2024. So welcome back, or for those who are taking the course or haven't taken, this is 5-week sessions in a row. We're gonna stop on December 4th, so we don't have a session on that date. However, we'll continue in December. All right. So welcome also to everyone joining online because we have a good crowd online, and for those who are here in house, welcome to the Dementia Society Center. My name is Herman Chica Alfonso, and I'm the education coordinator for the Dementia Society of Ottawa and Renfrew County. So today we start our series with brain health and the aging brain as well. So we are very lucky to have our speaker today, and is Dr. Andrew Frank. Dr. Frank is a cognitive neurologist at Bruyere Memory Program at Elizabeth Bruyere Hospital in Ottawa, Ontario. After finishing his bachelor degree in honors biochemistry at University of Calgary, Dr. Frank completed his MD at the University of British Columbia in Vancouver. He also completed his residency in neurology at the University of Ottawa. Following this, Dr. Frank undertook a subspecialty fellowship in cognitive neurology at the Mayo Clinic in Rochester, Minnesota. Dr. Frank clinical practice is focused on the diagnosis and treatment of neurodegenerative diseases such as dementia due to Alzheimer's disease. His clinical interest lies in the early detection of cognitive disorders such as mild cognitive impairment. Dr. Frank research interest centers on investigating also new pharmacological treatments and technologies for Alzheimer's disease. And we're very lucky to have our speaker today. And I ask also for a round of applause to welcome Dr. Andrew Frank. And welcome, Doctor.
Okay, thank you, Herman. All right, great to have you here. And the slides, Herman, okay. Thank you for coming in today and online as well. Well, today we'll talk about the brain. We'll talk about the functions of the brain. And as you know, these are functions that can be lost in dementia and Alzheimer's disease, which is very tragic because these brain functions are so central to who we are and what we can give in our own lives, but also to those around us. So we'll talk about the structure of the brain and functioning. We'll talk about how it's related to the heart and the lungs and the blood flow and the oxygen and the bowels, which provide the brain with our nutrients, our food and our oxygen, which generates energy because the brain requires huge amounts of energy to do all of the wonderful things that it does. And cognition and memory are what it gives us, and we sort of take it for granted until it's taken away. And how it changes as we get older, normally, and in future sessions, you'll learn about how it can change abnormally.
You don't mind just moving?
Moving this way? Sure. Should I go on this side, in fact?
It's not the other. I think it's, yeah, you're good there.
The prevention is how we try to maintain our brain function. Prevention of Alzheimer's and dementia, because in future sessions, lecturers will delve into the abnormal changes of Alzheimer's and dementia and how that deviates from normal aging. And so that's in a future session. Disease like Alzheimer's and dementia, other kinds of dementia like vascular dementia, Lewy body dementia, Alzheimer's dementia will be in a future session. Today is just setting the table of what's normal about the brain and what aging is. And part 3 will be about research and services in the area, and because we are absolutely trying to move the field forward towards new treatments for Alzheimer's and dementia, which have been incredibly difficult to discover. All right, so let's start with brain and the heart and the lungs. So the brain is 4.5 cups in volume, just 3 pounds. But we move forward. It is a huge energy usage. Go back, because it uses a lot more energy than its size would indicate. Here's how it's sort of broken down. This brain, our brain, has evolved over millions of years from smaller animals, from earlier animals. And over the millions of years, the brain has started very small in the brainstem area and then has grown forward, developing these other areas which have added on top of it. So it's sort of like a house with a very old castle or stonework underneath, with like more and more modern levels of the house built on top of it. So at the bottom of the brainstem is like the ancient stone castle with like newer eras of architecture built on top of it, culminating with the frontal lobe, which is the newest area of the brain. And so let's touch on what each area does, and you'll see what I mean. The brainstem helps us breathe, basically drives our breathing. So that's the most basic. And then right beside it is the cerebellum, is how we can move more effectively and survive in a world in which we need to move towards food and away from threats. And then on top of that is the temporal lobe, which are emotions in many ways, as well as memories, so that we can create emotions and memories based on what we encounter in the world so we can survive. The back part of the brain, this is actually a side view of the brain, if you hadn't gathered that, where it's the back part of the brain is the occipital lobe there. And that area is vision. So vision developed for us quite robustly, so help us sense the world, survive. Parietal lobe up there is more long-term memory. So what our temporal lobe creates new memories and emotions is then fed up into the parietal lobe as a kind of long-term memory, all of which helping us survive. And lastly, the final build on top of this multi-generation castle is the frontal lobe brings everything together, all of the new sensations and information, all of the old information, combining into a perspective on what's happening to us right now. Who are we? Where are we? And when? And what is happening relating to the present, the past, and the future, so that we can decide, not just react, but decide what to do next. And perhaps other animals have this, but perhaps humans have one of the most developed frontal lobes, allowing us to, in fact, create communities, create systems, create religions and philosophies, which have allowed us to essentially survive across the entire world, for good or for bad, becoming the dominant species on Earth, able to communicate across the planet and create vast financial and social structures, all from the frontal lobe, allowing us to see more than just what's in front of us, but in fact see into the future. It's quite something, isn't it? However, it can be lost. It can be lost through strokes, blockages of the blood flow. It can be lost from injuries, head injuries, and yes, it can be lost through dementia and Alzheimer's disease. This is sort of a view from the inside part of the brain, sort of from the middle view. We've turned it around now. So this is the back part of the brain now, and that's the front. And we're again seeing we don't see the brainstem and the cerebellum anymore. That's sort of taken away here. But we've got the temporal lobe, where the new memories are made, especially right here in the middle part of the temporal lobe, called the hippocampus. And that's where brand new memories are made. They're very fragile and are one of the most sensitive areas to injury, such as Alzheimer's. That's why when Alzheimer's begins, you lose new memories, short-term memory loss, because it's right here in the hippocampus that is so fragile, is one of the first areas that get damaged. And the emotions attached to that are also in the temporal lobe and the limbic system, which runs around in this gray area here. So notice when you have a memory, there can be an emotion attached to it. And emotional memories are far stronger than non-emotional memories. And it's all in this temporal lobe, hippocampus formation, limbic system where you get emotional memories. And you got the occipital lobe for vision, parietal lobe for long-term memory, and of course the blue frontal lobe, where it all comes together to help us plan and strategize and have insight into the bigger picture of it all. And this is microscopic because as big as the brain is, it's made of billions of these tiny microscopic neuron brain cells, each one of them alive and communicating with their neighbors in an incredibly vast network of tiny brain cells. It's like the internet. As if each of these tiny little cells was like one computer, it can communicate with other computers near to it and across all the way on the other side of the planet, which is like on the other side of the brain. A massive internet of tiny brain cells, creating circuits and complexity beyond our imagination, into the quadrillions and quadrillions of connections. Again, that is the complexity that probably allows all of this magic to take place, to allow us to sense the world and to remember and to process and to plan for the future. That is not, it seems like magic, but it actually is the functioning of these tiny structures. And if these structures are damaged through biochemistry or through trauma, then you lose the abilities that they were previously able to create. We have 20 to 100 billion of these neurons, each of them connected in vast ways with their neighbors, which creates unbelievable complexity. And because each of them, as they talk to their neighbors, this is a sort of connection between one neuron to the next microscopically. They release tiny neurotransmitters that helps them communicate with their neighbors. And that, there are many neighbors, and those neighbors connect to neighbors, and they can all transmit through these transmitters. And there's different kinds of transmitters. There are some transmitters that say yes to the neighbor. There are some transmitters that say no to the neighbor. So it's the amount of complexity that these cells in their networks can create is essentially inconceivable to us. And here's a drawing. This is just a drawing of how the neurons are microscopically floating on the surface of the brain to their neighbors and allowing connections, in fact, to travel all the way to the other side of the brain through the deeper parts of the brain called the white matter. And these neurons are on the surface of the brain, the cerebral cortex, we call it, and that's the gray matter of cells connecting by the white matter to other neurons across the other side of the brain. Like I said, like an internet in which one computer here could connect to another computer on the other side of the earth. These tiny brain cells can connect to another brain cell on the other side of the brain, which would be like an earth away to these tiny structures. So yeah, hopefully I've convinced you of the miracle that is the brain as a result of millions, if not billions, of years of evolution on our planet. And so the energy, these cells are alive, and they require energy to survive. And they require energy to build the neurotransmitters and send their tiny electrical signals along their bodies to their neighbors and across to the other side of the brain. That requires energy. And how do we do that? We need two things, and it's sort of obvious, but we need food, like glucose, and we need oxygen. So the food, as you know, we eat, and the oxygen, as you know, we breathe. And if you combine those two, correctly, you get energy. So that sounds simple, but of course it's never simple. In fact, it's again massively complicated, the chemistry that goes into combining glucose with oxygen to get energy. Massive, more complexity. And so let's say it starts with the breathing. And we know our lungs are important, okay? And we know our heart's important. We can move on. In the smallest sense, the lungs have these tiny sacs which bring the oxygen in, and then the oxygen goes into the blood through the tiny alveoli sac in the lung. And then that allows the blood with oxygen to go back to the heart. And we can go to the next here. I can do it. And then the heart is another beautiful miracle of circulation that brings in the non-oxygen blood from the body, goes to the lungs, picks up oxygen, then comes back to the heart. Very interesting, actually. Goes to the lung, then back to the heart to get pumped again to the rest of the body. So the heart actually has two separate circulatory systems, one directly to the lung to pick up the oxygen, then back to the heart, which then pumps it to the whole rest of the body, which includes the brain, where all of that oxygen can be dropped off. Yes, and look at that. This is the circulatory system of the arteries going from the heart to the brain with all the oxygen. It's like a tree. In fact, I think we've sort of borrowed some of the genetics of trees because we share, even though trees are plants and we are animals, we share something very similar in that we're both alive and that there's something similar in that the tree structure allows the oxygen to get to the brain in the same way that the tree structure allows all of its nutrients to move to all of the branches. It's very beautiful in a way, as you can probably sense. It's true miracle, what life is. And if you want to go to the next one, then the blood enters into the brain and it has to release its oxygen. This is all microscopic again, across what's called the blood-brain barrier, which are cells. These are astrocytes, are special supporting cells that support the neurons, which are the brain cells that I described before, and they support the blood vessels with all of these little plates. It looks like plates, but they're really just like cellular material that protects the brain from taking in poison. Because if you take a poison, it could come in, and this tries to protect the brain from poison, but we want the oxygen to come in. And by the way, we want the glucose. We're going to talk about, we want the glucose to come in as well. And that is coming from the gut. So we've got this incredible, unbelievable coordinated system to get the oxygen from the lungs in, crossing the blood-brain barrier, and we want the glucose to come in from the gut, from the food we eat, all of which is coming in through the blood vessels and having to cross through the blood-brain barrier. So yeah, the brain is 2% of our weight, but takes 15% of the blood. That's interesting. And 20% of the oxygen. And 25% of the sugar, glucose. Yeah, so you would think of that as sort of a hog, right? The brain is like an oxygen and food hog. And the other parts of the body would be saying, why does the brain get so much attention? But the answer is because the brain is us. We are the brain, we are our brain. And that's why you can do a heart transplant, but you can't do a brain transplant. Because if you put someone else's brain into your body, you'd be them. You wouldn't be you anymore. They would be you now. So that's the brain is us. So that's why the rest of the body doesn't complain. They understand that the brain needs the extra food and the oxygen because of the central reality of the existence, and because our existence is in our brain. And that's why I went into neurology, because I couldn't believe the complexity of the brain. And I wanted so badly to find a new treatment for the brain because I saw how Alzheimer's was destroying the brain. And I was hoping, and I'm still hoping, that we can find new treatments for the brain against Alzheimer's so we can save all of this complexity and beauty, so we can have longer, fuller lives, which is really something that I feel we are all very much desiring and justified in trying to create the best, longest lives for ourselves and our families. So here, This is the bowel. We eat all the time. The reason we eat, of course, it's delicious, but it's also because of the food, becomes the sugar. We break down the food. There are many nutrients, like vitamins and minerals. Those are really important too. But essentially, it's the glucose we need that is going to be combined with the oxygen to generate huge amounts of energy. And so we eat, and it is broken down in the bowels, and then it enters into the blood flow, which then goes back to the heart, you remember, and then it's pumped to the brain. So it's all this so beautifully coordinated. But interestingly, well, you've heard of the microbiome. These are bacteria that live in the bowels. They actually, even though they're not us per se, they actually create transmitters themselves that can feed back to the brain. So it's called the gut-brain axis, in that it's not just the glucose, it's also the bacteria that live in our bowels as well that we want to take care of, which can actually support the brain further. So that's, if you've heard of the microbiome, that's where that comes from, is that we want to take care of our heart, we want to take care of our lungs, but we also want to take care of our bowels, because that's where the food is broken down and also creates this nutrient and transmitter flow back to the brain. So every system counts. It's all a coordinated effort to keep us alive and thriving. So if the brain is thriving, then it can generate cognition. Cognition just means thinking. And as part of thinking, we have things like memory, which is our short-term memory from today, our long-term memory from years ago. Also, as part of cognition, we have language, which is what I'm using now, and you're hearing and understanding me through language. Again, another miracle of evolution, that humans can communicate like this. Here they are here. Memory and language. Orientation is where we are in space and time and who we are. And concentration is our focus in the moment. And our visuospatial is our ability to navigate. And our executive functioning, that goes hand in hand, or is found in that frontal lobe I was talking about. So the executive functioning in the frontal lobe is our newest creation, which is, again, our ability to take in information, see the patterns, make a strategy, and make it happen. That's the human way. I mean, other animals have that too, but the humans, in the complexity of planning and execution of activities, is, I believe, as yet unmatched on Earth. And so again, we got the basic breathing and functioning, hunger functioning from the brainstem and hypothalamus above it. And then we got the cerebellum with our movement. We got the temporal lobe, which is our memory and emotions. The occipital lobe, vision, parietal lobe, long-term memory, and frontal lobe is the executive function. Also, the language tends to be on the temporal lobe as well, on the left side. Interesting that the left side of the brain for almost every person is where the language is. Again, it must have been an evolutionary efficiency to have the language on the left side. Whereas the right side is not so much words, but more emotional tone of voice. Whereas the words are on the left side, and we use both of them to help our communication, feeding into our memory and emotions. Yeah, you can keep going forward. You can see some hearing on the temporal lobe, vision in the back, executive function in front, language on the side, just as we just said. Same here. You can see on the view from the in-between. And again, I did actually want to go back. We'll underscore how that middle part of the temporal lobe, the hippocampus, we have one on each side of the brain. That's the very site of the neurons that make brand new memory. So if you're going to remember anything of what I'm saying today, if it's interesting to you, that memory is going to be created right here in the hippocampus on either side, creating a brand new memory of something you may not have known before tonight. And then if it's interesting, then it can be fed up into the parietal lobe here, the green, where it can become long-term memory. And you might remember something important, like that the temporal lobe or side part of the brain is where new memories are made, and that the front part of the brain, the frontal lobe, is our newest evolutionary creation, which is where our executive function and planning comes from. If that is to become a new memory, it starts in the hippocampus and then it becomes long-term memory in the parietal lobe. It's all real. So it seems like it's ephemeral or ungraspable, but it's real at a microscopic level. That process of remembering is real. It's just happening at a microscopic level. And that if those cells that are doing that are damaged or destroyed, you will lose that ability. And so it's a concrete loss of function at a microscopic level.
There's a slide where you had like the different percentages of what takes up the brain.
Yes.
I just was wondering about two of them.
If you want to go back, Gemma. So this was the percentages of the energy usage.
Like, yeah, exactly. That one. That one. Yeah. Thank you.
And we can get you these slides. If you don't have them, we can get you these slides for later. These are publicly available for sure. No problem. So we won't break at this time. We'll continue forward and move towards aging. So aging is normal. This is the passage of time that we are all affected by. But the question is it, even though we can't slow down the passage of time, and the time moves at its meter, which is seemingly unchangeable in our reality, can we still slow down the aging process? We can't slow down time, but can we slow down aging? The answer is yes, because even though time is moving at a set rate, the way we age can move at different rates. We can age faster. For example, if we smoke, the effect of tobacco and the burnt materials on the body and the oxidation that it creates will cause us to age faster. However, if we stop smoking and maintain a healthy lifestyle, we can slow down the aging effect. So time moves at its meter. However, aging, the rate of aging can be changed. Here you can see the brain. On the left side is normal. Of course, the person did pass away because this is looking at the brain at autopsy. But they might have been a young person or aged at a slower rate, so their brain looks quite full or plump. However, on the right, this individual passed away perhaps with dementia, Alzheimer's disease, and their brain is much more shrunken. You can see the difference. We want to slow down the aging process so that our brain can stay as full and robust for as long as possible. And so it is always normal as we get older to feel slight declines in memory and concentration and speed. Because as we get older, the body ages on the outside, which we see, but it ages on the inside as well, which we don't see, but it happens. And so we will notice that we're a little slower to remember the word, we're slower to remember the name of someone. It may come back later. That's a good sign. If you forget something and it comes back later, that's a good sign. Because it means it was still there. The memory, it just took a little longer for the brain to run through its circuits, which we discussed earlier, and it took a little longer for it to generate the answer that you were looking for. But it was still there. So there's a slight decrease in speed of processing as we get older, but it doesn't usually affect our ability to function. We may have physical difficulties as we get older, like arthritis that makes it harder for us to lift things and function in that regard. But when I'm referring to functioning, I'm referring to mental functions, like the ability to solve problems and say things and communicate and think and remember. That's usually fine. Maybe delays, but it's little impact on our functioning from a cognitive point of view as we get older. So she says, age doesn't make you forgetful. Having way too many stupid things to remember makes you forgetful. That's true. But at the same time, the brain, even as we get older, can still learn things. It's never, you can't teach an old dog new tricks. Well, yes, you can. You can definitely teach an old dog new tricks because the brain can, it may take a bit longer, this guy. It may take a bit longer to learn, but you can definitely still learn. And I often say that people should learn new things and take classes and learn new skills at any age because it creates new connections. Those little neurons I showed make connections with their neighbors, and you can build new connections at any age. We call it plasticity, the ability for the brain to change at any age. Could take a bit longer, but it can happen. And I recommend it because those kind of connections make the brain more resilient to aging and injury. The depth and complexity of the network is the resilience against aging and injury. The more connections you have, the more you could lose before you notice any symptoms. The less connections, the more vulnerable. So, in addition to the brain aging, which causes this slowing, we age in terms of our breathing. We age in terms of our heart. We age in terms of our gut. So with the lungs, as we get older, yes, there's less oxygen transfer. So of course we want to stop smoking. But again, the anti-smoking campaign is now 60 years old, thankfully, and we want to continue, of course, the efforts to stop smoking. Decrease pollution. So yeah, we want to move towards a cleaner world, and we are slowly moving in that direction. Asthma, emphysema, creates an image like that on the right. If you're smoking, that creates severe damage to the brain, to the lungs, which decreases the oxygen transfer. And you heard we need that oxygen. And what about the heart? Well, what about the blood vessels? We've got this tree of blood vessels throughout the body. They harden through cholesterol, they get narrow, so therefore there's less blood flowing, therefore there's less oxygen moving, there's less glucose moving. And the less oxygen and glucose you have, the less ability to generate energy. And without the energy, there will be decreased brain function. There will be slowing of thought, like I was saying. And that is a normal part of aging to some degree. However, if there is blockage of a blood vessel, that is a heart attack in the heart. That is a stroke in the brain. And if you lose that, if you block an artery and you lose the oxygen completely, you will get damage to the heart. You will get damage to the brain. And some of that cannot be recovered. So yes, we want to maintain that circulation by maintaining, actually, we want to talk about high blood pressure. That high blood pressure should be on that list in addition to diabetes and cholesterol. So high blood pressure, diabetes, cholesterol, we want to manage those. Family doctors manage those because, oh, and there it is there, hypertension, because that's high blood pressure. We want to manage these well, because if you don't manage these, that blood vessel throughout the body will narrow and block. It will. We have to manage those, what we call vascular risk factors, meaning blood flow, blood vessel risk factors, to keep those pipes open, to keep the oxygen and glucose flowing. And yeah, the bowels too. We want the bowels to move well. I mean, you've heard about protein, very important. Carbohydrates, proteins allow us to generate our muscles and our tissues. The carbohydrates can be broken down into the sugars like glucose. We need that. Even fats, very important, can also be broken down to generate energy. Yes. And we want nutrients, vitamins, and minerals, and we want fiber to maintain mobility. Very important to maintain motility. Also, the fiber helps with the microbiome, which are the bacteria that help break down food and maintain that axis or connection between the bowels and the brain that I mentioned. We want to, of course, prevent diarrhea and constipation, diverticulosis or outpouching of the gut, all of which decreases its efficiency to break down our food into the nutrients we need to stay alive. We want to slow down the aging process. We cannot stop time, but we can definitely slow down aging. And that leads, I think, to one of our last topics tonight, which is prevention. We want to prevent heart attacks. We want to prevent stroke And yeah, we want to prevent Alzheimer's and dementia. We want to age at a slow rate to maintain our gut function, our heart function, our lung function, and our brain function. Okay, so here's things that we can do to slow down aging. Well, here, go back one. We want, less education is a product of our early life, so that sometimes we don't have control over that. But we want to maintain education. I would say we want across life education because it maintains the density of the connections in the brain. We want those neurons to have as many connections to neighbors as possible, so that the more connections we have, the greater resilience we have to any injury as we get older. Midlife, we want to have good hearing so we can continue to stimulate the brain through hearing. Same with vision, though. We want good vision, optimize our hearing and vision to stimulate the brain. Of course, we want to avoid traumatic brain injury. And that, of course, actually applies to early life as well for, helmets, for kids playing hockey. I mean, we've heard about this, football. We want to prevent brain injuries. We want to treat high blood pressure because the high blood pressure damages the pipes and narrows them. Even though you're pushing the blood through harder, you're actually damaging the pipes, so they get narrower as a result. So we cannot have uncontrolled high blood pressure. We have to control. We want to decrease alcohol because although alcohol is used for pleasure, it is toxic to the brain. So we cannot have heavy levels of drinking. We can't have binge drinking. If we just want very limited alcohol intake, in my view. And we want to treat obesity through healthy lifestyle, physical activity, mental activity. We want to decrease cholesterol to healthy levels. We want to stop smoking. We want to treat depression. We want to improve social connections because social connections are so stimulating to the brain that they generate more connections. We want physical activity. We want to treat diabetes, high blood pressure. We want to decrease air pollution. Here's the vision. So it's all the things I've been talking about. And you've heard about all these things. I know you have. But here's a reminder that they help us age slower in terms of the gut, in terms of the lungs, in terms of the heart, and in terms of the brain. So these are proven factors through scientific study that slows down aging and allows ultimately, in my view, ultimately allows the brain to function better and maintain all of its miraculous functioning for years longer. And so here, again, these are all the factors I just talked about in more detail. We can get to these slides. And so, interesting, in addition to that healthy lifestyle I talked about, sleep. Yeah, sleep is part of a healthy lifestyle. And because you want high quality sleep. You do not necessarily want sleep apnea, which is snoring that is disturbing the depth of your sleep, because then you never get deep sleep. You want quality sleep. It's not the quantity, it's the quality of sleep. If you want to head back one, Herman. We want quality sleep so that you're actually getting into the deep sleep, no sleep apnea, no major leg movements disturbing your sleep. That way, in the deep sleep, you can actually, and it's been shown, cleanse the brain. Some of the injuries to the brain, including Alzheimer's, which is composed of proteins in the brain, and this will be talked about in future sessions, the buildup of proteins like the Alzheimer protein can be cleansed from the brain during deep sleep. So it's not quantity, it's quality of sleep. And quality of food, for sure. Those nutrients I talked about, the health monitoring, all of the active lifestyle, that is getting at the heart of those factors we just talked about to try to help us age slower. And now the next slide, they seem to show that if you got too little sleep, that's not good. Too much sleep is actually not good either. It's showing that there's actually more dementia if there's too much sleep, because it could mean that the quality of the sleep is poor. So you're sleeping longer to get more sleep, but it's poor quality. So it's the middle ranges of what you want. You want the middle range of sleep that is quality, not quantity. And yeah, here are the latest food guide recommendations where, yeah, we're getting protein and we're getting fruits and vegetables, which have nutrients and fiber. There's fiber in there. Whole grain foods with carbohydrates, but with fiber. You see that it comes back to, I think, the proteins and the whole grain carbohydrates and the fiber with nutrients and fresh fruits and vegetables. A lot of this is derived from the Mediterranean diet, which is, I think the heart of this is from the Mediterranean diet, where the sources of protein may be from light meats, sort of less red meat, more chicken and fish, fresh fruits and vegetables, and whole grains, without too much high salt and without too much processed sugar. We do need sugar, but we don't need it all at once. The idea is that you want to take sugar in like carbohydrates, but have a slow release. Instead of the spike of sugar that you get from high sugar foods, the spike is hard on the body because it makes the blood sugar go up like a spike, and that is hard on the body and brain to process. So too much of a good thing is still too much. You want that sugar, but you want it gradual. I think the body wants everything gradual. The body does well in balance. It does not like huge ups and downs. The body does not want huge ups and downs of blood pressure, does not want huge ups and downs of blood sugar. It wants even support for blood pressure, blood sugar, oxygen, everything in balance so that the functioning is, I'm thinking gentle, but it's also sustainable. And that's where long, healthy lives come from, is that sense of balance and avoiding the extremes. Even exercise itself. Exercise is good, but we don't necessarily want extreme exercise and then no exercise. We want a gradual, we want a consistent supply of modest to light exercise over time. The body would love that, to get light exercise all the time instead of no exercise, then extreme exercise, and then no exercise. That's the kind of thing the body can't stand. And that hurts the body. We want a gradual, consistent, balanced exercise and diet every day. So we want the breathing to be successful over time. We want to take care of our lungs. We want our heart to be successful, maintaining the circulation and the blood vessels to remain open, and the gut to maintain. And actually, this is the exercise, is physical activity, showing that even 20 minutes, just 20 minutes per day, has significant benefits on brain structure. 20 minutes per day. That's amazing. You don't need extreme exercise. You just need that consistent supply of light exercise on a regular basis. And it can make a huge difference compared to nothing. There's a massive jump from doing nothing to doing 20 minutes a day, a massive jump. So don't feel like you got to run marathons. You don't. You just have to do 20 minutes a day. And that can be such a difference compared to nothing.
Is there a heart rate need?
I don't think so. I mean, if you go deep into the literature, I bet you might find some recommendations. And yes, I've seen the charts at the gym where they say, here's your target. But in my view, trying to get to that level is secondary to actually getting to the exercise and doing it. Having a wonderful walk outside with the fresh air, where you're walking either even just around the block, is for 20 minutes is infinitely better than not getting out of the house at all, regardless of whatever heart rate you get to. And here, but this is cognitive exercises. This is a kind of computerized cognitive game that tries to give adults a kind of cognitive exercise program. Excellent concept, and I support it. But does it have to be this computer game? It does not. Any activity where you are generating thought, learning something new, generating strategies in a game, or artistic creation, that is incredibly stimulating to the brain. Just like a walk around the block, trying to play a strategy game, it's like a walk around the block for the brain in the cognitive sense. You want your physical activity and you want your cognitive activity. And you want your social activity. These are three strategies to exercising the brain to allow it to slow down the aging process. That's what we're talking about here. And so social engagement, participation in social activities, decreases the likelihood of cognitive impairment in this study from Spain. So it's unquestioned. This is just one of many studies that shows that physical activity, mental activity, and social activity, and perhaps the Mediterranean diet or something like that, can make a big difference in slowing down the aging process of the bowels, of the lungs, of the heart, and the brain. So we lose brain cells. We do. As we get older, brain cells die. We have billions, but we lose thousands a day. I know it sounds very sad, but at the same time, you know, the body is affected by aging. And we, again, I think the key to focus here is that aging takes place, is normal, but we want to have it take place at the slowest possible rate. We call that prevention, and it's through the healthy lifestyles we've talked about tonight, and trying to build resilience of the brain to any forces that might damage it. Again, aging is normal, but there are these forces that are beyond aging, like Alzheimer's and dementia, that we want very much to delay and prevent. So plasticity is the ability for these brain cells to generate more connections, and that can take place at any age. So engaging in these stimulating activities saves the brain and in fact strengthens the brain in some ways. We may lose brain cells, but we can increase the connections of the ones that remain. So while the total number of brain cells may go down over time, the number of connections can go up of those that remain. Because each of these brain cells, they're shaped like stars. They can send out new arms to their neighbor. The ones that remain can send out a new connection. They can build that. That's what they do with all that energy that they're creating. They can build a new arm to their neighbor to create a new connection. So while the number of cells goes down, the connections go up. And what a great way to try to stave off the aging process and create resilience to a force that could damage the brain like Alzheimer's.
Can they recognize a damaged pathway and reroute around it?
Yes. In the case of stroke is where the blood gets blocked. So I showed you the pipes. If you block one of those pipes of the tree to the brain, there's no oxygen or glucose getting through. Those brain cells need that food constantly. You block that, you're going to have the brain cells damaged and possibly being killed within minutes. That's why strokes are such an emergency. And after a stroke, the brain cells that survive around the area that was damaged will reroute. And that's the rehabilitation process. So even at a microscopic level, yes, as we lose brain cells to aging, the cells can reroute around areas that are lost. And that's what we're talking about, maintaining that stimulation to sort of push those neurons into forming those new connections to their neighbors, to maintain the density of the network, even though the number of computers is decreasing. And aging is normal because the passage of time is normal. But there are these diseases that go beyond aging that not everyone gets, but some get. And they accelerate the destruction of the structure that I've talked about. All of the miracle of the memories and emotions and language and executive function of our planning and knowledge of ourselves in the universe. All of that miracle can be destroyed by Alzheimer's and dementia. And we're not going to delve into that tonight because that'll be the subject of the next lecture, is that Alzheimer's is the buildup of a toxic protein that starts normal, but then builds up too much in some people. And when it builds up too much, it becomes a poison in the brain. And the brain cannot clear it fast enough. So it just keeps building up in the brain, damaging all those neurons and their connections, killing them. A stroke can do it in a second, like with the blockage, but the Alzheimer's process with its proteins can take years. But over those years, the brain cells are destroyed, and with the destruction come the symptoms of short-term memory loss and loss of functioning and abilities, which can just devastate an individual and their families. And if you've had experience with that, then you know what I'm talking about. And that goes beyond aging. That is much more severe. And yes, we want aging as slow as possible, just like we've discussed tonight. But what we really want as well is a cure for Alzheimer's disease. And we're not there yet. But in these lectures, we're going to talk more about what causes Alzheimer's and the hope for the future. Research is underway at Briere looking at that. We have tested many medications for Alzheimer's, and we still are. Here's a clinical study currently underway at Briere that's testing the microbiome. For those of you who are not squeamish, if you provide a stool sample, we have the ability through our collaboration with the University of Ottawa to measure the bacteria that are in your stool. And we are attempting to provide a prebiotic, which is a special kind of sugar that is not sugar for us, it's sugar for the bacteria. And we're trying to alter the bacteria to see if we can create a more healthy bacterial profile, which can then help memory. Because there is a connection between what our bowels are doing and what our brain is doing. And so we're trying to adjust the microbiome to try to create better memory. And there is a phone number there. Actually, we want to head back. There is a phone number there. It's sort of small here. Oh, yeah, this was here too. This is another study we're doing. This is all at Briere with our collaboration. We are trying to measure new kinds of ways to measure brain function, because what we want to do, we want to tell you, is the memory change that you may be experiencing, is that normal aging, which we know happens a little bit, or is it Alzheimer's? We want to differentiate normal aging from Alzheimer's. We want to slow down aging. We want to cure Alzheimer's, but we want to know the difference between those. And we want to be able to predict the future, that if you're experiencing a memory loss, is it normal or Alzheimer's? And we do that through the work we do at our memory clinic, but we also are looking at new ways of detecting what's normal and what's not. So we're using computerized memory tests. We're using electrical measurements of the scalp. We're using eye movements in this one study. So we have multiple studies trying to see if we can develop new technologies to tell us who is going to develop Alzheimer's and who will not. So lots of research underway. We've got some handouts, I think, Herman, that you can take. We've got phone numbers that you can call if you're interested in any of these studies, because there's no question that our clinic and research institute at Briere downtown, and we're proud of this, here in Ottawa, is trying to move to the cutting edge of new treatments for Alzheimer's and new technologies for Alzheimer's to detect who has it, who does not, and if you do have Alzheimer's, we want new treatments very badly. And if you want to continue on, I guess that brings us to the end of our story, and I'd be very pleased to answer any questions. Thank you for your attention.
Hello. All right. Well, thank you so much. I think if anyone has any questions for Dr. Frank, we can I'll also pass the microphone so the audience online can also hear. Anyone has any question for Dr. Andrew Frank?
Yeah.
I'll speak up.
Okay.
Question I have is, where does this, high demand for sugar?
Mm.
My mom has Alzheimer's, and there's, just this amazing drive and reach
Oh,
for sugar on an
wow.
ongoing basis. You know, when you go into the grocery store, it's right to the chocolate bars, it's the cookies. Where does that come from?
Great question. Okay, so for those online, if you didn't hear, the question is, in someone who has been diagnosed with Alzheimer's and dementia and is having some changes in behavior or in this case, food preference, and really gravitating to high sugar foods. Okay, so we are evolved to seek out sugar because we need it to survive. So our evolution has driven us to find foods with sugar. In our current world, that has been exploited somewhat, and we have a lot of foods that have too much sugar as a method of selling these foods to us. We probably do not need that much sugar, but a lot of these products have that much sugar, and it sort of plays on our enjoyment of sugar when we eat it, which we've evolved. As the brain changes with Alzheimer's, some of our inhibitions are taken away. The circuits which inhibit or decrease some of our behaviors are lost. So we might seek out high enjoyment activities, whereas our brain tries to control ourselves and bring back those and perhaps suppress some of those behaviors because they may not be in our best interest. As we develop Alzheimer's, we may release some of those behaviors, which feel good, but may not be in our best interest. So in Alzheimer's and other dementias, people may excessively eat sweet food because of that enjoyment factor, which we're evolved to have, without as many of the circuits in place that inhibit that partially destructive behavior. Because again, if we have too much sugar, it is harmful on our body and creates diabetes, obesity. So normally we would inhibit that, but unfortunately with Alzheimer's, some of those inhibitions are lost. And so the drive to just have that enjoyable activity of the high sugar food is excessive. So therefore, someone, a loved one, a caregiver, can help someone not engage in a destructive behavior of excessive high sugar food and try to maintain the moderation, because moderation's okay. These are wonderful foods and enjoy them, but we don't want them to become excessive, even as Alzheimer's is removing that inhibition to stay away. Great question.
Can we refer to the recordings of these sessions later on?
Yes, the recording will be available shortly. Okay, and we're gonna share it afterwards. Anyone, any other question?
I
Okay.
do have another one. Don't want to be the only one.
That's quite all right.
That's okay.
It's the tipping point between short-term memory and long-term memory.
Mm.
Is there like a jumping off point at which a short-term memory becomes long-term?
Yeah.
And cannot a long-term memory become a short-term memory if you tap into it?
Oh, that's so interesting. The was beautiful question of when exactly does short-term memory turn into long-term memory? And could a long-term memory become a short-term memory again? That's an even more fascinating question. So it's around, I think, a few days to a week or two that a short-term memory starts to move out of the temporal lobe and into the parietal lobe to go from short-term memory into long-term memory. So days to a couple weeks. That's not very long, is it? But that's about how long it takes. Because short-term memory is really about the last 10 minutes, the last couple hours, that's short-term memory, maybe the last day or two, and then it starts to move out into the long-term memory. And that's all it takes. It's a very important process. Short-term memory has to stay. In Alzheimer's, actually, those structures are damaged, so the short-term memory doesn't stay. It could be lost after just 10 minutes. And there could be no recollection of what happened just 10 minutes ago because all of those structures in the hippocampus are being damaged. So there's no short-term memory, therefore no long-term memory. Then it is possible, if you think about a long-term memory, you go back into your mind and you think about something that happened 15 years ago or something like that, and you start to experience it again. It can be a pleasurable experience. It was a good memory. Of course, it can be a negative experience if it was a bad memory. Interestingly, as you experience that memory again, it's probably entering short-term memory again because you brought it back to your consciousness and you might be reliving it in your mind. Not in reality, but in your mind. And it's probably creating a short-term memory because you're reliving it in that moment. So it goes through the hippocampus again. Maybe the memory is even altering itself slightly. Yeah, you might be rewriting. In fact, you are. You're rewriting that memory slightly as you re-experience it. Hopefully for the better. Maybe it's a defense mechanism as we may take negative memories from the past and make them more positive. Hopefully not the opposite. I wouldn't want to take a good memory and turn it negative, but more perhaps in the negative memories turning positive, and maybe that's a defense mechanism to help us remain maybe more comfortable with past memories and help us survive. Any other questions? Anything online here, Mark?
Okay, yes, I see couple questions online. So the first question is glucose or ketone a super way of fuel the brain?
So is glucose. So glucose is the sugar we talked about. And you mentioned ketones, right? So yeah, ketones are not sugars. They're another sort of chemical molecule that can be taken in through food, can be generated by the body, often from fats. And they can definitely be broken down into the smaller elements that can be combined with oxygen to make energy. So while glucose is the most famous of all of these structures that can be broken down with oxygen to form energy, ketones definitely, and fats, can be broken down into their constituents to be combined with oxygen to generate energy. So we don't just need glucose, we have the whole ketone fat pathway that can also be combined with oxygen to generate energy. But notice, you need oxygen. Both of those require oxygen. So the non-negotiable is oxygen. And that, of course, is our breathing. And you know what can happen if you stop breathing. For whatever reason, it is an emergency. You need it all the time. And the food to generate oxygen for the brain, because without it, we lose consciousness. And that's what happens in these medical emergencies. We lose consciousness as the brain requires that energy usage all the time. That's how precious it is.
Right. So another question here is loss of memory a form of dementia?
Loss of memory is a general term, and you can have normal loss of memory as we get older. It's, as I mentioned, it's more like slowing of memory. Could still remember it, just might take a bit longer. Then there is the loss of memory that can occur with Alzheimer's disease. A toxic protein in the brain prevents new memories from being made. It's more serious. And those symptoms can become apparent to oneself or to others around them. And then there's the word dementia, just asked about. The word dementia, and we'll cover this in next lecture, is dementia is defined as losing memory, but losing independence as well. That's the definition of dementia, is losing memory and independence. And yes, that's serious and not normal aging. We feel aging can slow memory, but does not take away independence from a memory point of view. Dementia is memory loss and losing independence. It's not normal, and it's often caused by the Alzheimer's protein. And that's where the next lecture will pick up on the definition of dementia and its causes.
Yes. So on the side note, there's a question here. How can you diagnose what type of dementia someone has? If there's no treatment, at the end of the day, does it matter what type of dementia someone has?
The next lecture will cover the different types of dementia. Dementia is a general term for any memory loss that takes away independence. But what is the cause of dementia? The most common cause is Alzheimer's, the buildup of the Alzheimer's protein. But it's true, there are other causes of dementia. Lewy body dementia is a buildup of a different kind of protein. Frontotemporal dementia, a different protein. Head trauma, a different structure. Stroke, these are all causes of dementia, different causes of dementia. Question was, is there any purpose to figure out exactly the cause if there's no cure? Well, we hope that we are moving closer to new treatments. And again, a future lecture may touch on a new treatment that targets the protein of Alzheimer's. There's a new treatment that has been approved in the States, we hope will be approved in Canada, that removes the protein of Alzheimer's. In that sense, if we had a treatment like that, we would want to know, is it Alzheimer's? Because we would use that specific medicine for that specific cause. So there is some value to knowing the cause because it can help us with the treatment. The new treatment, it goes by a complicated name, lecanemab. So that is a new treatment which has been approved in the States and elsewhere that tries to remove the protein of Alzheimer's. So it requires a diagnosis of Alzheimer's type dementia, dementia caused by Alzheimer's, and it's complicated. A future lecture will discuss how it's an intravenous medicine. So it's not so easy to use and requires a lot of special scans and monitoring. So it's not for everyone, it's not easy to use, but it is advancement. And it really speaks to the previous question why we will, in the future, try to diagnose the exact cause of dementia so we can target the treatment to it.
Okay, so we're getting two more questions here from the audience. Someone asks, "What is autism? Does it show physically in the brain? Does it show up physically?" In the brain?
So now I am not an expert in autism or autism spectrum. Please note that that is more of a lifelong condition. The Alzheimer's disease is not a lifelong condition. These toxic proteins of Alzheimer's build up often later in life, 60s and beyond, sometimes 50s. But autism, a more lifelong condition. And the exact structural changes in autism would be spoken to by other experts in that field beyond myself. But please note that the presence of autism does not necessarily increase the risk of Alzheimer's disease. And Alzheimer's disease does not cause autism. So again, autism is a lifelong condition with neurological structural changes to the brain that are different than Alzheimer's disease, and therefore would require completely different perspective on treatment, and again, more so throughout life.
Okay, so one final question here. I think this is more personal, but someone is saying that my father's siblings and I are concerned with memory brain health of our mother. So the question goes to mostly my mother or her mother and being assessed for driving. I think it's talking about driving and losing driver's license. So how can we do something about it, manage that?
That's right. So I think from your question, you have some concerns about a loved one, partly because one of the implications of memory loss, of abnormal memory loss, moving towards dementia and Alzheimer's, one of the implications is driving safety. Now, this is a very sensitive topic, and it can lead to fractures in families. It can lead to fractures in the medical office between patients, families, and their physician. And so it definitely speaks to an importance to testing memory by a family doctor, perhaps testing memory in a memory clinic like where I work, to try to determine, does someone have Alzheimer's or not? Again, that's one of our huge focuses, trying to determine who has Alzheimer's and who does not have Alzheimer's. Because if there is Alzheimer's, we want to know, is there a risk to driving? And I think that it is valuable to get tested for memory because we want to prevent a car accident before it happens. And so the tool that I use most often if I'm worried about someone's diagnosis of Alzheimer's and worried that they may be at risk for an accident, is I recommend a driving test. This is an on-road driving test. So the benefit of getting tested memory, having testing of memory and getting a diagnosis of Alzheimer's or not, is that it may open the door to a driving test which can determine definitively if someone's at risk for an accident or not. And so I hope I'm answering the questions when I say that it's worth pushing a loved one to get their memory tested, possibly at family doctor, possibly at a memory clinic, and yes, even to consider a driving test. Because if there is a risk to driving, you have the opportunity to stop or prevent a car accident before it happens.
Right. Well, so thank you, Dr. Frank, for that great presentation. I just like to remind everyone that next week we're going to have part 2, and it's about type of dementia. So if anyone, wants to sort of like watch this presentation again, don't worry, it's going to be recorded. You don't have to memorize all that today. Thank you for coming. Thank you. And I really appreciate that everybody showed up to this session. And thank you, Dr. Frank, again. And have a lovely evening, everyone.
Thank you, everyone.